Welcome everyone. So we will be discussing Indian contribution to science. This is a book which is compiled by Vigyan Bharati, and this is one of the chapters which is there for the VVM examination. Chapter 3, Chemistry in India, a survey. Chemistry, as we understand it today, is a relatively young discipline. It took shape in 18th century Europe after a few centuries of an alchemical tradition, which was partly borrowed from the Arabs. Alchemy was a semi esoteric practice whose ultimate goal was to turn base metals into gold and discover an elixir of life that would grant immortality. Other cultures, especially the Chinese and Indian, had alchemical tradition of their own, which included much knowledge of chemical process and techniques. Early chemical techniques in India, we can trace some technical techniques all the way to the Indus civilization and its antecedents. The Harappan metallurgical skills have been described in the module of metallurgy in India. Pottery, called for a control of processes such as heating, fusion, and evaporation. Bread making involved complex treatments of minerals, including bleaching a beet with a solution of calcium carbonate, then heating it in a kiln so as to leave permanent white design on it. Harappans also experimented with various mortars and cements made of burnt limestone and gypsum among other components. Finely crushed quartz, once fired, produced fines and synthetic material. It was then coated with silica, to which copper oxide was added to give it a shiny turquoise glaze. Faience was then shaped into various ornaments and figurines. The addition of iron oxide gave a greenish blue tint to glazed pottery, when manganese oxide resulted in a maroon color. Such techniques survived the end of Indus civilization and found their way to the later Ganges civilization, often with innovation. Glass manufacture, for instance, numerous glass beads and other artifacts have been unearthed from Taxila in the northwest to Nalanda in the east and Arikamedu in the south. So this is a Harappan bangle made of fans. Pigments were another area for skilled chemical practices and were required for painting. Witness the famous Ajanta murals, as well as dyeing of cotton and other textiles. Interestingly, sources of pigments were not limited to organic material but included mineral sources from carbon to arsenic sulfide or copper acetate. So, here if we see that carbon, it was from lamp black, arsenic sulfide yellow ochre, or copper acetate, which was verdigris greenish blue in color. Atomism in Vaisesika, although it did not translate into actual chemistry, the Indian notion of atomism deserves a brief mention. Atomism, or the concept of that matter is ultimately made of indivisible building blocks, appeared in India few centuries BCE as part of philosophical speculation, in particular in the Vaisesika, one of the six philosophical systems of India. The author of the Vaisesika Sutra came to be known as Kannada, literally eater of particles, and may have lived any time after 500 BC. In this system, all substances were seen in an aggregated form of smaller units called atoms, which is Anu or Paramanu, which were eternal, indestructible, spherical, suprasensible, and in motion at primordial state. They could form pairs or triplets. Among other combinations and unseen forces caused interactions between them, the Vaiseska system identified 9 types of substances, dravya 1 to 5, 5 elements, earth or prithvi, water or up, fire or tejas, wind or vayu, ether or akasha. Time, kala, space or direction, dik, the mind, manas, and the spirit of knower, atma. Besides, substance had 24 different qualities including fluidity, viscosity, elasticity, and gravity. While fluidity was related to water, earth, and fire, viscosity was unique to water and gravity to earth. Distinctive characteristics of sound, heat, and light were also discussed, which often came close to later discoveries of physics, although lacking a mathematical apparatus, they did not evolve into scientific theories. Chemistry in early literature. We find plentiful evidence of knowledge of chemical practices in some of India's early literature. Kautilya Arthasastra is a well known text of governance and administration authored probably in the 3rd or 4th century BC during modern era. It has much data on prevailing chemical practices, in particular, a long section of mines and minerals. It also discussed the various characteristics of precious stones, pearl, ruby, beryl, etc. Details of fermented juices from sugarcane, jaggery, honey, jambu, jackfruit, mango, etc., and oil extraction. The fundamental two texts of Ayurveda and Charaka Samhita and Susruta Samhita, both dated a few centuries CE. Not only do they turn to a wide range of chemicals for medical use, metals, minerals, salts, juices, but they also discuss the preparation of various alkalis, which is khara, which is regarded as one of the 10 arts kala. Alkali are described as mild caustic or average and are prepared from specific plants. After the plants have been burned together with some limestone, their ashes are then stirred in water, filtered, and the resulting solution is concentrated by boiling, to which burnt limestone and corn shells are added. Such alkalis were used to treat surgical instruments as well as thin sheets of metal like iron, gold, silver, intended for preparation of drugs. These texts also speak of organic acids extracted from plants such as citrus or tamarind. Varamira Barhat Samhita, an encyclopedia of sorts composed in the 6th century CE, has a chapter on preparation of numerous perfumes out of 16 fundamental substances mixed in different proportions. Indeed, perfumery and cosmetic formed a major branch of chemical practices in classical and medieval India. The Barhat Samhita also includes various recipes, for instance, for preparation of glutinous material to be applied on the roofs and the walls and houses and temples. It was prepared entirely from extracts from various plants, fruits, seeds, and barks, which after being boiled and concentrated were then treated with various resins. It would be interesting to test and scientifically access such recipes. Several texts, such as Kama Sutra, contain a list of traditional 64 arts which an accomplished person was supposed to master. Among them, interestingly, we find knowledge of gold and silver coins, jewels and gems, chemistry and mineralogy, colored jewels, gems and beads, knowledge of mines and quarries, which testifies to the attention paid to such fields. The Classical Age. The alchemy in India emerged around mid 1st millennium CE during the Gupta Empire. Its origins remain hard to trace, and scholars have proposed that it received inputs from China, where the discipline is well attested as early as in 2nd century CE. Whatever its beginnings, India alchemy soon took a stamp of its own. It was variously called Rashasastra, Rasavidya, and Dhatuvada. The word rasa has many meanings, such as essence, taste, sap, juice, or semen. But in this context, it refers to Mercury, seen as one of the most important elements. Mercury was identified with male principle Shiva, while sulfur, Gandhaka, was associated with the female principle Shakti. And most alchemical texts were presented as a dialogue between Shiva and Shakti. Inter- Intriguingly, the genders of mercury and sulfur are the other way around in Chinese alchemy. This is in tune with the Tantra philosophy, and indeed, in alchemical practice, preparations, and processes, mercury was regarded as divine and assumed to be potent enough to confer not only the longevity but also occult powers, including invisibility and leviation. There is a vast alchemical literature authored by savants such as Nagarjuna, Govind Bhagat, Vaghata, Somadeva, Yasodhara, among many others. The Rasa Shastra texts discuss many chemical substances and their interactions. They were categorized as follows: Maharasa, or eight major substances: mica, tourmaline, copper pyrite, iron pyrite, bitumen, copper sulfate, zinc carbonate, and mercury. Uparasas, or eight minor substances: sulfur, red ochre, iron sulfate, alum, and orpiment, arsenic trisulfide, realgar, which is arsenic sulfide, collyrium, compounds of antimony, and tin stone of cassia tin dioxide. Navaratnas, or nine gems, including pearl, topaz, emerald, ruby, sapphire, and diamond. Dhatus, or seven metals: gold, silver, copper, iron, lead, tin, zinc. A few alloys such as brass, bronze, combination of five metals were also included. Poisons, visha or garala, and plants. Among the later, over 200 are named in the text. Their identification is not always certain. Plants were required in particular to treat or digest metals and minerals. In the quest of elixir of life, mercurial preparations were supposed to bestow long life and youthful vigor. Mercury was sometimes called Amarta Dhatu, or immortal metal. In practice, some Ayurvedic and Siddha medicines were derived from various metals and minerals, but only after those had undergone complex purificatory process so as to remove their toxic effects and make them fit for internal use. For instance, all the mercury compounds are regarded as poisonous. Cinnabar, which is mercury sulfide, went through 18 complex process samskaras, including rubbing with various medicinally efficacious plant juices and extracts, incorporation of sulfur, mica, alkaline substances, etc. The resulting mercury compound was then declared fit for consumption and believed to lead to the body's regeneration. Similar process exhibit in Tamil alchemy and the Siddha system of medicines, which developed in addition special techniques in connection with the naturally occurring salts, especially three of them: Mapu, consisting of rock salts and various carbonates. So here we have the cinnabar, you can see the mercury sulfide. Transmuting base metals such as lead, tin, or copper into gold was another pursuit of alchemy and involved five operations: smearing, throwing, pouring, fumigating, and impact. Here again, mercury, sometimes called Swarnakaraka, or maker of gold, often played a major role. The process described in the text are quite elaborate, extending to many days. Their precise details cannot often be followed, however, as there are uncertainties about some plants, minerals, or their treatments, but transmutation was not regarded as purely mechanical process. Honesty, self-control, sincerity of purpose, devotion to God, obedience to the Guru, and faith in Rasavida were regarded as essential for the Rasavadan to achieve success. Actual practices were kept secret as the goal would fail to reach if they were divulged and to uninitiated. Devotion to God, obedience to Guru, and faith in Rasavidya were regarded as essential for Rasavadan to achieve success. Actual practices were kept secret as the goal would fail to be reached if they were divulged or uninitiated. Claims of actual production of gold out of the base metal extend to recent times, such as 1941 demonstration recorded on a marble slab at New Delhi Lakshmi Narayan temple. Naturally, such claims must be viewed with the greatest skepticism. More likely, the color of the metal was so altered that it appeared golden. Indeed, some texts refer to gold looking alloys of silver, copper, and mercury. In alchemical tradition, the transmutation of metals may also be taken as a metaphor for the body's own transmutation through elixir of life, which was the ultimate objective of Indian alchemists. In any case, the quest for this elixir or transmutation of the base metals did lead to actual and valuable chemical techniques in the medical field in particular, and eventually contributed to the Ayurvedic and Siddha pharmacopoeias. Laboratory and apparatus. The text carefully spell out the layout of laboratory with four drawer and esoteric symbol, that is Rasalinga in the east, furnaces in the south east, instrument in the northwest, etc. Besides motors of stone or iron and pestles, bellows to heat the furnace, sieves, pans, tongs, scissors, and earthen or glass vessels. The apparatus includes specialized instruments indigenously developed for heating, steaming, distilling, trituring, or extracting substances. So, if you see here, it's a laboratory that is there. Okay, next. So, let us mention just a few of them. The Musa yantra or the crucible, usually made of white clay or the of the earth of an anthill mixed with rice husk, iron dust, chalk, etc. Such crucibles would have various shapes and sizes depending on their application. The Koshti Yantra for extraction of essence of metals, consisting of two rimmed vessels with fire urged from above and a side blower besides the metals, and the vessel would be filled with charcoal. The Svedani yantra, the big earthen vessel used for steaming, the dola yantra, in which the pot is half filled with a liquid and a suspended substance absorbs the liquid vapors. The Patna yantra, for sublimation or distillation, it could be upward, downward, or sideways. The second was Adhana yantra, in which a paste of mercury was coated at the bottom of the upper vessel, allowing the vapors to descend in the lower vessel and combine with the substances kept there. So before we go ahead, we have in the left with the Koshti yantra, and here we have on the right we have the Dola yantra. Then we have Dhupa yantra, used for fumigation of gold leaves or silver foils with fumes, sulfur, or substances. So here you see we have Adhana yantra and other side is Dhupa yantra. Although India's chemical tradition were rich and varied and fused elaborate techniques with a spiritual component, although they may not have directly contributed to the birth of modern chemistry, they did result in considerable practical application, especially in the fields like metallurgy, gemology, and medicines.